Okay, so it's pretty easy to recognize a cave when you're inside the cave. But the question is, how do we recognize the presence of caves from the air? And so in the first picture there on the left is what's it going to look like as long as that cap rock is in place. So we mentioned that down here is where you're going to have your limestone that is eventually going to form a cave. But then covering the limestone is going to be a cap rock. And so let's say that this cap rock could be made of shale or it could be made of clay, but it's going to be made of some kind of a material that does not allow the groundwater to flow underground and get into the limestone. So where is water going to flow if it can't go underground? Well, it's going to have to flow on the surface. So in that first picture there on the left, it shows that you've got some kind of a hill over here, and then it goes into a valley, and then you got another hill over here, and then here is where you're going to have your river. So this is going to be a normal dendritic river pattern on the surface of the earth, where you've just got rivers doing what you normally think of a river. So from the top down view, you might have, let's say this river empties into this river, and then there's another stream that empties into this stream, which empties into the river. So that's going to be a dendritic flow pattern for the surface rivers. All right, now let's take a look at the picture that's on the right. So this is going to be what's going to happen once something happens to this cap rock, so that water is now able to get into the ground. So groundwater is going to be flowing through these cracks. It's going to be getting into the limestone, and you should be noticing that little pits are starting to develop into the limestone. Those are eventually going to become the caves. Now, what does it look like at the surface? Well, you'll notice that, let's say above this crack right here, groundwater could flow directly into the ground instead of having to flow this way and get into the river. So water is pretty lazy. So the water is going to take whatever the easiest route it is in order to go down. So it will go downhill into a valley and then get into a river if it can, but if it finds an easier way to get down into the ground, it's going to do that. So what this is going to do is it's going to start to develop sinkholes. So sinkholes are going to be where this, so down here, this material is going to start to be eroded away. Okay, and then it's going to start to erode into the limestone like this. Now eventually it can get to the point where maybe this material on top of it is going to fall into the sinkhole. And so then what you end up with is going to be like a pit up here. And so if you look at that picture, you're starting to see kind of looking like a moonscape, where you've got all of these pits, and each of those pits are going to be a place where the water is going into the groundwater instead of going into the river system. Okay, another thing that can happen is that the water that is going in this river system can abruptly end. So let's say that here's some water, but then it goes into the ground right here. So when it does that, then that means that all of this water is going to dry up. Now, also another thing that could happen is that groundwater, which is down in here, it might surface somewhere else. So that this is going to be called a losing stream right here. So the stream just abruptly stops and disappears because it's going underground. And then maybe over here, all of a sudden you've got a spring where water is coming up out of the ground, and then it continues into the river system. So what you're going to end up with is a disruption in the river system from the air, where you've got some parts of the river are disappearing and then other parts where the river is appearing. Okay, another thing that can happen is that this river here that used to be on the surface, now let's say, is making a big cave system right here. So this river that used to be on the surface is now running through this cave underground. So that eventually this cave might get so big that it's going to weaken this material right here. It's going to fall into the cave, and so now the cave is exposed to the air up here. And so that's going to then be called a solution valley. So a solution valley is going to be, it used to be a cave, but now the roof of the cave is collapsed, and now you have an extra large valley. But that valley was not carved by the river. So originally it was carved by a river, but then that water in the river went underground and carved it under the ground, and then when it collapsed, now you got an extra large valley. So that's going to be a solution valley. And so in this picture on the left is advanced stages of karst, and you can see now that you have a very well developed cave system under the ground. You notice that some of the caves are above the water table, and so in those parts of the cave you have your stalactites and stalagmites, and then under the water table is where fresh caves are being dissolved. And so you'll notice that there is a lot of sinkholes above the ground, a lot of disappearing streams, reappearing streams, and solution valleys. And then in the picture that is over to the right is a really advanced stage of karst development, where all that you've got left of the original material are kind of like mounds. So you got mounds over here and mounds over here, and then in between the mounds, that's where the groundwater used to be. And the top of the ground used to be way up here, but it's all collapsed, and these mounds here are all that's left of the original limestone that was there. Okay, so here is a picture of a sinking stream, so that you have the water is coming towards you, and then you see that the water is emptying into a pool, and then it just stops there. So the water does not continue on, unless of course it's a very, very heavy downpour of water. So if water is coming into the cave system faster than the water can leave, then water will actually flow on the surface of the ground. But then as soon as it slacks off a little bit and the water can start to drain into the cave system, once again these river systems will become sinking streams. Okay, then you got a picture of a sinkhole over there where the ground has collapsed underneath it. And do you remember when we talked about volcanoes, what was it called when you had a magma chamber and then you had the ground up here, and then for some reason the magma in the magma chamber went away, so now you've got this big hole in the ground? And what happened when the ground collapsed into it? What was that called? It was a caldera. So as long as this magma chamber was filled with magma, it would support the weight of all of this rock on top of it. As long as you've got a cave system that is full of water, that water will help support the weight of all the rocks that are on top of it. But once that water drains and you just got a hole in the ground, then it may not be able to support the weight of the material, and so now you're going to have a sinkhole. Okay, when sinkholes combine together, Then that's where you're going to have your solution valley. And at the end of a solution valley, you could have a entrance to the original cave. And so here in southern Missouri, we have a cave called Smalling Cave, and it has a gigantic entrance to the cave, which is something like 20, 30 feet tall, and then it goes into a valley. So that's a solution valley. That's where the cave used to be. And then where this big opening is at, that's where the cave currently is located at. All right, so we're going to take a break, and when we come back, we're going to start talking about what hazards does groundwater pose.